yesterday we talked about antiderivatives and integrals and kind of basically went over the notation and thought about, like, if you're given the derivatives, how do you find the equation that you would have started with? Okay, what did we have at the end of every interval?
Plus C.
We had something, ooh, that's not what I meant to do. Okay, let me change that up. We had something, and then we had plus C. Okay? This is what we're going to call a general solution now. And this is kind of like talking about between definite and indefinite. Don't get too caught up with these words, but just know that from yesterday to today, there's different types of integration, just like there's different types of derivatives. There's derivatives where we just solve for x. There's ones where we actually find the slope at a given point and all that kind of stuff. There's just hang with me on this. So a general solution looks like this, plus c. But a particular solution is when we actually take a point on the graph and find c. In other words, you won't have plus c by the end of your answer if the directions are to find the particular solution. Okay, so let's look at this example, and I'm going to go ahead and tell you that some of you, you're going to be able to look at this and figure out what the answer is at the end. On the AP test and in this class, I'm going to want you not just to show me what the answer is, but to prove that it's true. This means that you're going to have to use good notation. Okay, so I'm going to give you some steps for solving these differential equations. So notice that there's no integral sign here. We're going to have to do that part for ourselves, all right? The first thing is, if you have y prime, and this also goes if you had like f prime or anything prime really, what you're going to do is you're going to replace it with dy over dx. Okay, what this will do is kind of set us up to solve this differential equation. Okay? So that's the first step, and that's pretty easy. We already knew that y prime and dy over dx were the same. All right, the second thing is I'm going to call this separate your variables. Okay, what I mean by this is we're going to have an x and a y, and right now they're kind of all jumbled together. I want the y's on one side and the x's on the other side. Before I integrate, I have to do that. I can only integrate y's with y's and x's with x's. Okay? And so later on this may become more difficult, but for right now this step is just a one-step process. What is that step? So look, dy is on the left. I like that.
Multiply by dx.
Oh, sorry.
I just want to multiply by dx. So really what this looks like, and I'm going to go ahead and put 3x minus 1 in parentheses, it really just looks like moving the dx over to that side. Okay, and I want you to notice, we have y's on one side, x's on the other side, and we have a d on both sides. This frees us up to take the next step, which is to integrate both sides. And this is why we had to have our variables separated, because you don't know how or even if it's possible to integrate x's and y's together. Okay, we only know one variable at a time. All right, and so we're going to put the integrating sign there. And when we integrate the left-hand side, it may be helpful for you to consider there to be a 1 there, especially right now, because you might not be sure how to integrate dy. But what is the antiderivative over here? If we integrate 1 dy, what do we get? We just get y. Good. The right side, we're going to have to do a little bit more work. And I just want to reiterate this over and over. We can only integrate when we have these d's next to it. If those aren't there, we're missing part of our integration. We messed up, in other words. Okay, what is the antiderivative of 3x squared? X cubed. Good. Remember, we're going backwards. We're not taking the derivative. We're saying, what is something that when you take the derivative, you get 3x squared? Okay, what's next? Minus x, and then we have our plus c, right? Okay, now there's 2 more steps to this process. Okay, step 4 is done for us here. It's solve for y. And in fact, all day today, this is already going to be done. All right, we don't really have to worry about this. But later on, when we get into more complicated problems, the solve for y part is going to be done, and so we'll already have it as one of our steps, and it won't be that hard to do those new types of problems. And then the very last thing we're going to have to do is find c. Now, c represents any number. I have no idea what c is. In fact, it truly could be anything. And we're going to look at what this looks like graphically here in a minute. But in order to find c, I'm going to have to be given some kind of initial condition. Something about just regular old f of x or regular old y. And usually, or what we're going to really say is this can only happen if you're given a point, meaning given an xy combo. So let's look at, this is the same problem, by the way. All right? So all 6 of these graphs are the graphs of y equals x cubed minus x plus some number. All right? And so the one in the middle, see how it crosses? What do you think the what's the y-intercept of the one in the middle? 0. So what is c? 0. Okay. What is the c value then of the one on top? 5. So the equation on top would be x cubed minus x plus 5.
So it's essentially like the b and the...
Yeah, it's the y-intercept. So c here is the shift. I don't really want to say so much it's the y-intercept because that could actually change, but it is definitely the vertical shift. Okay, it's the vertical shift up or down. So that's what's different about all these graphs. But what?
Kind of like a point of interest, like concave up.
Well, in this case, it changes concavity at that point. It wouldn't have to be that way on every problem. So what's the same about all 6 graphs? I want you to think calculus.
It's like they have the same slope.
They have the same slope, same derivative at any given x value. So let's talk about that. Let's take a -1, all right? Whatever the slope of the tangent line is on this curve, it's the same as that curve, it's the same as that curve, it's the same as that curve, that curve. It may not look that way, but when you actually identify it, you can see that that's true. The slope of the tangent line is the same at any given x value. That should make sense because what's the derivative? Yeah, 3x squared minus 1, right? It doesn't even matter what that number is. So we've kind of come full circle here with the whole derivative and antiderivative thing. All right, so again, back to our question is, how do we find c? Now, I really help you out here. I tell you, first of all, we have to have this point. We have to have the point 2, 4. So really, if you're given this graph, all you got to do is find the one that has the point 2, 4, which is actually like bolded, so it's really easy to even find. Follow that line, and the c value is -2. So my particular solution is going to be y equals x cubed minus x minus 2. Okay? What we had before was the general solution. This is what we're going to call the particular solution. All right. So do you think we're going to be given a graph every time?
No.
Why would I ask that, right? Unless the answer was no. So we got to think about how can we do this algebraically. So let me rewrite the general solution again. How can we use our point and our general solution to find c?
Could plug in the numbers.
Plug in the numbers. So 2's being plugged in for x, and 4 is going to be plugged in for y. And then you're just solving for c. So I have 4 equals 8 minus 2 plus c. 4 equals 6 plus c. So c equals -2, which is the exact same thing we got when we looked at the graph. But we're not going to be given the graph, so this algebraic strategy right here is how we're going to find c. Okay? So it's not really that bad. Well, let's move to the second page and practice this. Sometimes on these problems, they're going to do some of these steps for you. So if you notice on 2, the dy over dx is already done. You remember before we had to change it to dy dx. So what's our next step? I need to multiply the dx to the other side so that I have dy equals negative 1 over x squared dx. I have the y's on the left, I have the x's on the right. For now, the y's on the left is pretty much always going to mean dy, but that's not true for all problems that will ever exist. But I'm just kind of setting us up for being able to do problems in the future. Before I integrate both sides, do you think it would help me to rewrite this?
Yes.
Definitely it would. How should I rewrite? Negative 1 over x squared. Yeah, negative 1 x to the negative 2, and you didn't have to put the negative, or sorry, you did have to put the negative there, but you didn't have to put the 1 there. All right, now we're going to integrate both sides. And you're going to start to see a lot of patterns emerging here. Like for instance, last time we integrated dy, we got y. We get it again. Okay. Over here, what's the antiderivative? Sometimes when we get into these exponents, it gets harder. So leave a space, write your x, and add 1 to your power. Remember, antiderivative is backwards. So what's my new power? Negative 1. And if you just want to use the strategy from yesterday, write your existing coefficient and divide by your new power. So just 1. And so how could I check to see that this works? Yeah, take the derivative. Y prime, or dy over dx, okay, good. X to the negative 1 would be negative 1x to the negative 2. That's the same. And then the derivative of c would be 0. Probably, if this were on a multiple choice question, they would simplify it. And I'm not so concerned that you do simplify, but I want to make sure you understand how to, because this is actually going to help us get to the next step. If you had left your answer like this, I wouldn't count off for that. There's no problem. I'll show you where this would be helpful. So that's the general solution, okay? We did that part. Now we got to find the particular solution. This means that I need to use the point. In other words, I need to let x be 1/2 and y be 3. So I'm going to plug 3 in for y, and in place of x, I'm going to put 1/2. I think for most of you, doing 1 divided by 1/2 may be easier than 1/2 to the negative 1. I'm not sure. But in general, this might have been easier. So what is 1 over 1/2?
2.
2. So what's c?
1.
1. So my final answer? There you go. And this is what we call our particular solution. And you have to be given an initial condition, a point, on your graph. It is possible that on a multiple choice they may kind of combine these to get the common denominator. You have something like that on your after party. If you haven't started that yet, you need to get going on that. It's the one at the top, at the back of the page. Your answer may look something like this, but all the answer choices are just one fraction. So common denominators, you're going to get similar to that. All right, I want you to try to do 3 on your own. When you find C, I want you to check with your neighbor, because if you get C right, it's very likely that you did the whole problem correctly. So go ahead and try to do C on your own. All right, let's go over this, because I'm hearing some differing of answers. So once you get to this part and you take the antiderivative, you should have gotten y equals 2x cubed minus x plus c. If you mess up here, your c is for sure going to be wrong. Okay, so I think it's worth the time just to double check and make sure that when you take the derivative, you get what you started with. Like 3 times 2 would be 6, take 1 off the power, okay, good. Derivative of negative x is negative 1. All right, again, this is the general solution. All right, so that is half your answer. When you're using this, goes in for y? 0. And then the 3 goes in for x. So you end up getting 0 equals, okay, not 3 cubed is not 9, which happens a lot, but it's 27. So 54 minus 3, that's going to make 51. So that means C is negative 51. Anybody think that was weird? You must have done it wrong because it's such a weird number. That happens sometimes. So my final answer is going to be y equals 2x cubed minus x minus 51. Now, I get that there's a lot of chances to make mistakes here. That you know what you're doing, but you make silly little mistakes. This is why I'm really going to encourage you to check your answer. So there's 2 ways you can check your answer. If you plug a 3 in, you should get 0. If you don't, you messed up. You also should be able to take the derivative of this. In other words, make sure that y prime is what you started with. You know how to do both of those things really well now. Those are both old things. So even though it's easy to make a mistake, it's really easy to check. So I want to make sure that you're doing that. There's no reason why you should have a wrong answer. You may be stuck and not know what your mistake is, but you should be able to know if you made a mistake. All right, so we're going to do one more example. It's this number 4 right here. And so if you see what's different about it is I have second derivative. And I'm giving you more information. Okay, so let's think about this. I can move this up. Earlier I wanted to do this. I need a little bit more room. Here we go. Okay. So how do I rewrite f double prime using the d notation? D squared y over dx squared. And that's going to equal 6x. Okay, what do I do now? Yeah, so I have d squared y equals 6x dx squared. And now I'm supposed to integrate. So we haven't done this yet. Okay, but it's actually pretty easy. When you integrate d squared y, you're left with just dy. You can almost think of it as like the integrating took away one of the d's. All right, what happens when you integrate 6x? 3x squared. Don't forget your plus c. And also, we're left with a dx. I don't want you to think of it just as you take a d away or whatever. It's just, we have dy squared, we integrated, we get dy. You have dx squared, you integrate, you get dx. Okay? Before I can, I know I'm going to have to integrate again if I'm trying to get all the way back to f of x. But before I do that, I need to use this piece of information right here. So, do you see something that looks like f prime? So, is dy the same as f prime?
No, dy over dx is.
Dy over dx is. Okay, so from here, and hopefully you're leaving more space than I am, because I'm writing too big. But if I divide back over that dx, and I'm doing this because that's the same as f prime. In other words, if I divide dx, I can cross that off and say, oh, that's the same as f prime, and then I can use my point to find c. Y'all see that? So what number am I gonna plug in for f prime? 13. And I'm gonna plug 2 in for x, and we're just gonna go ahead and solve for c. So that becomes 13 equals 12 plus c. So c equals 1. Yeah.
Okay, so I went ahead and did the rest of this problem. Is that c the same as what it's going to be with the second
No, the c is changing, constantly changing. And we use the same letter, and in fact, your book likes C1, C2, C3, and some other teacher books should teach it that way. We're just going to use C every time, but it's always changing. It's always a different number. So how am I going to do this?
You just plug it in and then.
No, I'm asking myself a question. How am I going to
I see.
move every? Oh, that's so genius. I mean, it's not genius. It's just common sense. But, thank you. All right, so here we go. So let's go back to this step right here, okay? Let's rewrite this as dy equals 3x squared plus 1 and then dx. I used to use this other thing called convey, and this is the first year I'm using smart. It works a lot better, but obviously I didn't know that part. Okay, so now I'm going to take the derivative again, okay? And again, I know I can, not take the derivative, integrate. I know I can integrate because I have d's on both sides. That's the only way we know we can integrate both sides, because there's already a d there. So again, this from here on out, it's just going to be like the other problem. Y equals, what's the antiderivative of 3x squared? X cubed, right, plus x plus c. And now we're ready to use the f of 1 equals 4. I extended the page again. I don't know how I didn't know that. All right, so we're going to plug 4 in for y, 1 in for x, and the rest of it, this is now just like any other problem that we've been doing. So c then is going to equal 2. And my final answer is y equals x cubed plus x plus 2. You could write this instead of y equals. You could say, well, it told me to find f of x, so I'm going to write it as f of x equals. That is not too big of a deal right now, which one you put. Okay? Yeah. It is long for one problem. I had to extend the page twice.
Can we have like a sub?
All right. Now, in all these steps, do you think it's possible that when you do this by yourself, you might make a mistake? So, how could you check your answer?
Work backwards.
Work backwards. You should be able to take the derivative. First of all, you should be able to plug 1 in and get 4. You should be able to find the derivative, plug 2 in and get 13. Then you should be able to take the second derivative and get 6x. Here's the thing. You know how to do that stuff really well. There should be no doubt in your mind whether or not you did the problem right or wrong. Finding your mistake is difficult sometimes. But you should be able to know if you did it correctly or not, okay? Really easy to check.